Have you finished drawing the figure? Done? Now pay attention. Pay attention now. If they are remaining, you can complete it later on. But that was the time that was by which you should have done it positively. Now, I am putting the question to you. You need to answer at a time. All of you should give the answer. For a concave mirror, if a ray of light is traveling parallel to the principal axis and incident on a concave mirror, then reflected ray will pass through the focus, right? If the ray of light is incident along the focus on the concave mirror, parallel to the principal axis. If the ray of light is passing through the center of curvature incident onto the concave mirror, it retraces the same path in opposite direction, right? And if it is incident on a pole, it obeys the laws of reflection and gets reflected, okay? Now, if I am having the ray of light incident along the principal axis, incident on a pole, so it will retrace the same path in a opposite direction. Reflected ray will be traveling along the principal axis away from the mirror, okay? Now what happens in convex mirror? For a convex mirror, the ray of light is incident parallel to the principal axis. You have to change the language. You have to say that it appears to be passing through the focus. It is not actually passing through the focus. It appears to you to be passing through the focus, because then you have to extend that reflected ray in a backward direction. Then it will appear to you to be traveling or starting from the focus there. Okay? If you are having the ray of light incident along the focus, will it be traveling towards the focus for the convex mirror? You are having here a convex mirror. This is representing the principal axis. You are having the focus here, center of curvature here, and it is directed towards the focus. Means you will be having a dotted line up to this part, and then the light will be traveling along this direction. Then center of curvature to this particular point, this will be a normal. This will be giving you angle of incidence. It is directed towards the focus but not passing through the focus. Then you will find that the ray of light will be reflected along this direction with angle of incidence and angle of reflection equal. Are you getting this part? On the other hand, if I am taking the similar case, that you are having the ray of light traveling parallel to the principal axis, like this, then from center of curvature to this particular point, you will be having this as angle of incidence. Then with the same angle, you will be able to see that the ray will be traveling along this direction here. It will appear to you to be traveling to the focus. Barabar hai? If it is incident at the pole, suppose the ray of light is incident at the pole here, then it will be traveling like this with angle of incidence equal to the angle of reflection, right? And you are having the ray of light incident along the center of curvature, directed towards the center of curvature but not touching the center of curvature. Then it will be reflected backward, retracing the same path. Okay? Have you done this? Give the heading, formulae for the mirrors. Formulae related to the mirrors. The first one, the focal length of the spherical mirror, the focal length of a spherical mirror of radius capital R is given by, can you write down the formula? Focal length is given by capital R by 2, where R is the radius of curvature. Okay? For a concave mirror, focal length is negative. So mention there. For a concave mirror, focal length is always negative. For a convex mirror, focal length is always positive. Next number. The power of the mirror, is defined as P is equal to minus of 1 upon focal length when this is expressed in terms of meter. When the focal length is expressed in terms of meter. Or it will be written as equal to minus of 100 divided by focal length expressed in centimeter. The unit of power is called or it is denoted by capital D. It is coming from the word dioptra. Dioptra. Where di stands for through. Optra is you are able to see through it. So power of the lens is expressed in terms of diopter. Optra is standing for visibility also. When you are putting on the lenses, you are able to see through the lenses. So it's a power of the lens that is expressed in terms of diopter. Now it's very clear that for a concave mirror, you are having focal length to be negative. So power will be positive. Am I right or not? For convex mirror, you are having the focal length to be taken as positive. So power here will be negative. So you should always remember this, that focal length for the concave mirror is taken as negative. So power will be positive. Focal length is positive for the convex mirror. So power will be negative. Write down the third point. If a thin object of linear size O is situated vertically on the axis of the mirror, at a distance u, from the pole, and its size I is formed and its sides I is formed at a distance v from the pole, at a distance v from the pole, magnification is defined as small m is equal to size of image upon size of object. I upon O का मतलब होता है, you can put it as size of image upon size of object. Or it will be written as minus of v upon u, that is equal to minus of image distance upon object distance. Now size of image is greater than the size of object, m will be taken as greater than 1. Size of image less than size of object, m will be less than 1. I is equal to O, m will be equal to 1. This is telling you that image is greater than the object. It means that this is a magnified image. Magnified image. This will be diminished image. And this will be of equal size. Image will be of equal size as that of the object. So if you are having magnification negative, magnification is negative, you are having image inverted. Magnification is positive, you are having image that will be defined as erect. हो गया? Write down the fourth point. If an object is placed at a distance u, if an object is placed at a distance u, from the pole of a mirror, from the pole of a mirror, and its image is formed, and its image is formed at a distance v, at a distance v from the pole, distance v from the pole, then 1 upon v plus 1 upon u is taken as 1 upon focal length. in this formula, to calculate unknown, in this formula, to calculate unknown, comma, known quantities are substituted with proper sign. Known quantities are substituted with proper sign. This is the mirror formula we are using. Now, there are different forms of it which will be useful to us. For example, I can multiply throughout by V so that I will have 1 plus V by U is equal to V upon F. Can I write down this formula? Can I write down like this? Now, if you look at the magnification, that magnification is having a formula minus of V by U. Able to get that? So can I write down this relation as 1 minus of M is equal to V upon F? Right? So I can rewrite this relation as 1 minus of M multiplied by focal length will be giving me the image distance. If I'm calling this as 1, this is the second form of it. Now, if I am able to get this value of V here, then I can make another formula coming out of it. 1 upon V, I am substituting this value, 1 minus M multiplied by F plus 1 by U is equal to 1 upon F. So, I will be transferring this term to this side. So, I will be having 1 by U is equal to 1 by F. This will become minus onto that side, minus of 1 upon 1 minus M into F. Am I right? Am I right or wrong? अरे आ रहा है ख्याल में या नहीं? So can I write down this relation as 1 upon F? I'm taking this as plus sign, 1 upon M minus of 1 into F. डिनोमिनेटर में से माइनस साइन को बाहर निकालोगे तो यहां माइनस आ जाएगा, ये -1 हो जाएगा, ये प्लस M हो जाएगा. माइनस अपॉन माइनस है तो ये प्लस आ जाएगा यहां पर, राइट? So if I solve it further, I will be having here 1 upon U is equal to 1 upon F. In a bracket, you will be having the first term 1 plus 1 upon M minus 1. I am taking 1 by F common. So I will be able to have this relation as, this will be 1 by F in a bracket M minus 1 plus 1, यानी M upon M minus 1. So you will be having the object distance U is equal to M minus 1 upon M multiplied by F. So if in a problem I am given the magnification and focal length, I can find out the object distance as well as image distance. So for that, these two formulas are there. In addition to that, I can solve this equation 1 as focal length is taken as equal to product of V into U upon V plus U or U plus V. Can I write down equation 1 in this manner? So that is one more form of the relation that we can work on this. Another important thing is that if you are having the object at focus, so you will be having U is equal to minus V minus of F, because you are talking about object at the focus, concave mirror. So अगर आप concave mirror की बात कर रहे हो, so for a concave mirror, for a concave mirror, if you are keeping the object at focus, so what will be the distance measured, positive or negative? Concave की बात कर रहे हैं हम, तो you will be having this as the situation. If this is the focus here, you are having the center of curvature somewhere here, so you will be having from pole the distance to be measured, u will be taken as equal to minus of f. Object is present here. बराबर है? If you remember, today we have said that object distance, whether it is a concave mirror or a convex mirror, will be always negative. Do you remember? यानी हमेशा the value of u will be taken as negative. Focal length for the concave mirror, is it positive or negative? Focal length, the light will be traveling from left to right. Concave mirror है. Concave mirror के लिए focal length कैसा रहेगा? It will be negative. So you will be substituting in this formula 1 upon v, right? Plus 1 upon u, the value of u will be 1 upon minus of f, because object is at minus f, is equal to 1 upon minus f, because focal length of the concave mirror is negative. So if I transpose this to this side, you will be having 1 by v is equal to 1 upon f minus of 1 upon f. So this is giving you 0. So image distance will be taken as equal to. So that is why we have drawn the figure in that manner. If you are having the object at focus, where will be the image formed? Able to get it? But at the same time, if I substitute these values here, that magnification is given by minus of v by u. So you will be writing here minus of, image is at infinity, that is minus infinity will be taken here. Why minus infinity? Divided by minus f, because image will be formed at the infinite distance onto this side. So if you solve it, what you will have? Magnification will be turning out to be minus of infinity. It is telling you magnification is negative. What is the meaning of magnification negative? Image will be inverted and it will be very, very small. Sorry, very, very big. Right? So this is how we have to do the analysis. तो ये फॉर्मूले आपको ख्याल में रखने हैं, कैसे यूज करना है वो मैंने बता दिया है. So this is actually a picture. Now, anyone having any question on this part which we have shown here? कोई स्टेप जानना है, कुछ पता करना है कि कैसे करना है, क्या करना है? Any question? Now pay attention. You have to draw the ray diagram in this orientation. I am drawing the table, so that table form should be copied on both the pages, because you will require more space to cover the part which we are working now. Now what we are doing, normally in the book they give you the directly the what we can say the ray diagram. I don't want you to see the ray diagram first, but do the calculation and draw the ray diagram accordingly. And for that purpose, this table is going to be extremely important, where description and everything will come mathematically, not by memorization. Otherwise, what happens in a table, we memorize the description of image and we try to remember it. But when you do that, the logic is not getting built up. To bring up the logic in that whole process, we are having a tabular form that is to be copied. First, we'll be working for a concave mirror and then for the convex mirror. We'll work on it separately. So this is all about the concave mirror. So for the concave mirror, you have to put down the table here. Concave mirror. Obviously, the first thing will be known to you very well. Serial number. The second part will be position of object. Position of object will be the second column, where you will be describing the object distance u. U is standing for object distance. After that, you are having the formula 1 by V plus 1 by U is equal to 1 upon F. For doing the calculations, this formula will be in use. After that, you are having magnification is equal to size of image upon size of object is equal to minus of V upon U. Magnification calculations will be done. After that, you will be having a bigger space for the ray diagram. It will require a bigger space here. Then you will be having description of image. This is how the table will appear to you. तो ये सारी चीजें आपको करना है. You have to use the formula for it and get the answer and the approach there. So you will require both the pages. तभी जो दोनों pages, the two pages will be in front of you and you will be able to see in one go the whole process. Are you ready? Now we require here the calculations and everything to be done. That is why the columns are provided here. The first thing that is given to you, position of the object, that object is at infinite distance. So you are having object at minus infinity. This is the meaning that object at infinity. Object is at infinity. Object distance will be always taken as negative, whether it is a convex mirror or a concave mirror. We should always stick to that light should always travel from left to the right. Okay? Now in this case, you are having object distance to be taken as minus of infinity. So can you calculate what will be the value of 1 by V? Image distance is to be calculated. You are calculating the value of V, that is image distance. For that, you are having this part. So if you substitute 1 by V plus, you are having here 1 upon minus infinity is equal to 1 upon focal length of the concave mirror. Focal length of the concave mirror is taken as negative. So you will be having minus of F here. So you will be able to solve. This term will be 0. So you will be having V is equal to minus F. So where is the image formed? So you can write down here, image is formed at the focus. This is the first part of description. If I substitute it here, magnification, you will be having magnification is equal to minus of V. So minus of minus F divided by minus infinity. So what you will have? Almost 0. It's very, very small. So you will be having the value here M that will be less than minus of 1. Am I right? Very much less than minus of 1. So this is telling you that the image formed will be diminished. Image is diminished. It is less than minus. M is turning out to be negative. What does that mean? it will be inverted image. So you will be having images diminished, inverted. Where it will be formed? Inverted image है तो कौन सा रहेगा? Real रहेगा या virtual रहेगा? What is the image distance? Image distance it is in front of the mirror. So this will be a real. So it will be inverted and real. मैंने figure निकाला ही नहीं है. With the help of mathematics, I am able to describe the image. Now, when I am drawing the figure, I should check that whatever description I have written, that should come out to be true. Now, in this process, what we do or what we suggest is this, that you should have a radius of curvature to be taken as around 4 centimeter. So, you have to set 4 centimeter in a rounder. The purpose is very clear, so that focus will be 2 centimeter. So keep that rounder ready with you. See that you are having the radius to be 4 centimeter. Focus will be at 2 centimeter there. The light should travel from left to right. So I will be able to show here a concave mirror in this manner. This is representing principal axis. This point is known as pole. So you will be able to show here the focus and exactly double the distance. You will be having the center of curvature. आपने center of curvature to the point P, CP distance लिया हुआ है 4 centimeter. And you are having the PF distance taken as 2 centimeter. Done up to this part. Now where should be your image? Where should be your image? So that is well defined now. So you should have the light or the object giving the light from infinity. So how are you going to draw the figure here? We have seen the 4 rays. I can take here the ray traveling parallel to the principal axis. I can take the ray traveling through the focus, through the center of curvature towards the pole. Any 2 rays are sufficient for drawing the figure, but minimum 2 rays are required. In this particular case, I'll take here the ray of light traveling through the focus and directed in this manner. What will happen? It is going to be traveling parallel to the principal axis. Like this, it will be traveling. Okay? And you will be having the second ray traveling through the center of curvature, and it will be parallel to this line. What would happen? It will be retracing the part. So you will find that at the focus, because if the distances are properly taken, you will get it at the focus. There will be a diminished image that will be formed here. The third ray, I can take it parallel and moving to the pole. You can make the use of scale to draw the parallel lines, because parallel lines indicate that the rays are coming from infinity. Then it will be traveling along this direction. So you are getting here inverted image. You can check it out. We have written first and we are getting inverted image. It is a real because it is lying in front of the mirror. It is diminished and we have shown that it is very much less than 1. So it's a point image that you are able to get here. Able to get this part. So we have drawn 3 rays to show that how the ray diagram would appear. Now what do you mean by infinity? When you are keeping the object at infinity, what does that mean? Infinity means yes? Correct. It is any distance which is far more beyond the center of curvature, you are calling it as infinity. जैसे हमने यहां पर कितना फोकल लेंथ लिया है, 2 सेंटीमीटर फोकल लेंथ लिया है, राइट? रेडियस ऑफ कर्वेचर 4 सेंटीमीटर लिया है. अगर मैं 10 मीटर से रे ऑफ लाइट को इमेजिन कर रहा हूं तो इट इज इंफिनिटी. इवन 1 मीटर कैन बी कंसिडर्ड एज इंफिनिटी. That is why any longer distance as compared to the center of curvature, that is to be taken there. I have drawn the ray diagram at the last. I have described the image first. That sequence is to be maintained. This will give you an idea how the ray diagram should come in accordance with the theory. Done. Drawn the figure. All the 3 rays I have shown to be incident parallelly. When the light is coming from infinity, the light rays will be parallel to one another. How many of you finished drawing this part? Now in the second part, you are having here the object between center of curvature and infinity. Between center of curvature and infinity. Now you have taken the radius as 4 centimeter, focal length kitna rahega? It will be minus 2 centimeter, right? Because we are talking of it, you will be writing the focal length to be equal to minus of 2 centimeter as radius of curvature is taken as minus 4 centimeter. Am I right? Am I right here? Now, between center of curvature and infinity it is said. So you can take the value, any value beyond the center of curvature. For example, in this case, I can take here that object will be present beyond the center of curvature. So I can take this as minus of 10 centimeter. But if you are taking minus 10 centimeter, here you should have a space for minus 10 centimeter. Or better way, it is taken as minus 4, you can take it as minus 6 here, no problem. Right? Then you will be writing here the formula 1 by V, that is to be calculated, plus 1 upon minus 6 is equal to 1 upon focal length. The focal length is minus of 4. Oh, yes, minus 2. So 1 by V will be equal to, you are having this moving to this side, 1 by 6 minus of 1 by 2, multiply this by 3, divide by 3. So you will be having the answer here as, how much it will be? 1 minus 3, that is minus 2 by 6. Minus 2 by 6 यानी minus of 1 by 3 आएगा. यानी image distance will be minus of 3 centimeter. So magnification formula M will be equal to minus of V by U. So you will be having minus of V का value है आपका minus 3 upon U. Object distance you have taken it as equal to minus 6. So you will be having minus of 1 by 2. So is the value m less than minus 1 hai abhi bhi? M is less than minus 1, yes or no? So with this calculation, I can tell you this part, that image is formed at what position? It is formed at 3 centimeter. So if you are having the image that will be lying between focus and center of curvature, so you will be able to write down image is formed between focus and center of curvature. You can check the values and accordingly write down. Second, image is still diminished because you are having minus 1 by 2 here, so it is diminished. It is inverted because of the minus sign, and it is formed in front of the mirror, so it will be real. Now with this particular distances that you have taken, draw this figure here. You have to take a rounder, and in a rounder you should be able to take the distance as 4 centimeter. This is the concave mirror that you have shown. Then you will be having the principal axis that will be marked here. Remember the steps by which I am drawing the figure. Then you will be having focus somewhere here. Then double the distance, center of curvature. You can measure that this is focus minus 2 centimeter. And this center of curvature is going to be minus 4 centimeter. Object distance is at a minus 6 centimeter. So you will be having somewhere here the object present. The object distance will be taken from here to here. That will be taken as minus 6 centimeter. Right? I can show one of the ray traveling from object parallel to the principal axis. It will be passing through the focus. आपका फाइनल इमेज माइनस 3 सेंटीमीटर पे आ रहा है. माइनस 3 सेंटीमीटर यानी समवेयर इन बिटवीन द टू. यहां पर कहीं ना कहीं उसका आएगा इमेज का पोजीशन, क्योंकि माइनस 2 सेंटीमीटर, दिस इज माइनस 4. सो इन बिटवीन दैट इज दिस इज रिप्रेजेंटिंग माइनस 3 सेंटीमीटर. Right? Then the second will be traveling through the focus. And that will be passing through the parallel to the principal axis here. Now actually I am not having the straight line drawn, but I am just showing you. आपका इमेज यहां पर बनना चाहिए. Minimum 2 rays are required. You can show the third ray also passing through the center of curvature. Even that you can show here the fourth ray traveling through the pole, and from pole it will be reflected like this. मैंने चारों रेज निकाल के दिखा दिया आपको. यू कैन रिस्ट्रिक्ट योरसेल्फ टू 2 रेज, बट इट इज अ क्लियर इंडिकेशन एनी 2 रेज कैन बी ड्रॉन. हाउ मेनी ऑफ यू हैव कंप्लीटेड द सेकंड पार्ट? If you have completed, you can start with the third part. With the third part saying that you are having the object at center of curvature. So object at center of curvature. So if you are taking object at center of curvature, what will be the object distance? Minus of 4 centimeter. Your focal length is given to you as minus 2 centimeter. Can you calculate the value of V? Calculate the value of V. After that, you can calculate the magnification also by using the formula minus V by U. Write down the description of image and then start drawing the figure. Now you want to find out the image distance, you need not put the sign there. You have to only change the sign of object distance as well as the focal length. The sign that is coming there as a V will explain you the position of the image there.
So have you calculated the image distance? How much it is? Minus 4. So if image distance is minus 4, so your object and image are located at the same position. Are you getting that? So you can describe that particular part. Image is at center of curvature. First point will be image at the center of curvature. What will be the magnification? If you solve it, you will get minus 1. Minus 1 is telling you that it is an inverted image. It is a real image because it is formed in front of the mirror. And third important part is that equal size. The size is equal. Now keeping in point these three aspects, you can draw the ray diagram. We're done with the third part. Then you will be having the fourth part here. Object between center of curvature and focus. So can I take here object distance U is equal to minus 3 I can take. So I can take here minus of 3 centimeter. So you can use here 1 by B plus 1 upon minus 3 is equal to 1 upon focal length. Focal length is minus of 2. Right? So you will be having 1 by B is equal to 1 by 3 minus of 1 by 2. So you will be having 2 minus of 3 minus 1 by 6. So you will be having the value of B to be taken as minus 6 centimeter. The magnification will be taken as minus of B by U. So it will be minus of minus 6 centimeter divided by U. The value of U is minus 3 centimeter. So you will be having minus 2. So the size is double. Means you are able to get here image is formed. Image is formed beyond center of curvature. Beyond center of curvature. Am I right? Because image distance is minus 6 centimeter and your center of curvature is at minus 4 centimeter. So it is formed beyond the center of curvature. And you are having here the image is magnified. Inverted and real because it is formed in front of the mirror, not inside the mirror. So it will be here. So I am writing the description first. I am having everything in front of me. I will be using that data and drawing the picture there. The ray diagram is to be drawn at the end. So I will be having a concave mirror again. This is the principal axis. We are marking the pole here. You will be having the focus at a distance of 2 centimeter from the pole, then center of curvature here, and you are having the object present at what distance? Minus 3. So it will be object that will be present here in between center of curvature and here. This is the position of object. The final image will be formed at image distance you have calculated minus 6. So this is 4. So you will be having image present here that is representing minus 6 centimeter. Center of curvature वाला ये जो distance है that is minus 4 centimeter. Focus से यहाँ तक का जो distance है minus 2 centimeter. Object distance will be taken as minus 3 centimeter. should draw the figure in such a manner that I should be able to get the image at the point where I have written I. That is approximately, my distances are approximate. But if you are doing it with the scale, your figures will never go wrong. Now I can take the first ray that will be passing through this part parallel to the principal axis and passing through the focus here. The second ray would be traveling toward from as if coming from center of curvature. So I can show it like this. And on reflection, it will be traveling back along this direction. Somewhat like this it will be there. I can have the third ray traveling from focus along this direction and will be traveling backward like this. This is the position where the image will be formed and the size of the image here will be double. If you are taking the perfect distances as calculations are going on, your ray diagram will never be wrong.
There are two more conditions. Now, if you are taking the object at focus, what will be the object distance? If object is at focus, what will be the object distance? It will be taken as object distance will be minus 2 centimeter, right? Substitute the value in the relation 1 by v plus 1 by u is equal to 1 by f. Calculate the value of v and see what is the answer you are getting. Describe by using the formula for small m, the description of image is to be entered and then the figure is to be drawn. And the last part is, your object is between focus and pole. So what distance you are likely to take here? You can take the object distance as minus 1 centimeter. Use the formula 1 by v plus 1 by u is equal to 1 by f. M is equal to minus of v by u and try to get the relation, describe the image, and after the description of image, you will be having the ray diagram to be drawn. So how many ray diagrams will be there? I want you to draw 6 more ray diagrams for the convex mirror. Start drawing the figure. If you are having any doubt, tell me. We will give some time for that and then we'll proceed ahead. Okay?